Welcome to F453 by Jam. Today we are covering Chapter 7, Programming Techniques. Let's get into Stepwise Refinement, Programming Technique, Backus Neuroform, Syntax Diagrams, then Traversals and Notation. Stepwise refinement is the process of breaking a complex program down into smaller and smaller sub-programs until each one is manageable. You may have seen this in F452. The diagram of this process is called top-down modular design. Small parts of a program can be tested to make sure they work, and you can easily reuse parts for another program. Programmers can work separately to make different parts of a program, based on their expertise. One could work on networking, and the other could work on the GUI. Programming terms. You may have seen this in F452 also. A local variable has a small scope. It exists only where it was initialized. Global variables can be used anywhere in the program once initialized. A constant doesn't change while the program is running. Constants are useful for any things that are unlikely to change. For example, I don't see pi becoming 3.15 anytime soon. A function is a subroutine that returns a value to the main program. If you were to ask me 3 plus 2, I would return 5. A procedure carries out a task, then returns control to the main program. Have you not had lunch? I'll gladly make a sandwich for you. A parameter is a data item that has been passed to the subroutine. They are used as local variables. They are not to be confused with arguments, which are the original values that are passed to the subroutine. Parameters can be passed by value, where a copy of the argument's value is used so the original value isn't affected. It can also be passed by reference, where the memory address is passed instead. The effects of passing by value or by reference is shown to the right. A stack is used to track where the subroutine was called from. This is how recursive algorithms are possible. In this factorial algorithm, we recursively multiply until we reach 0. The stack will be updated, incrementing until the stopping condition is reached. It's then used to return to the subroutine that called it, until it gets back to the main program. Backus Neuroform, BNF, is used to define the syntax of a system or programming language. Syntax is defined unambiguously, which is important in syntax analysis. Here's how the syntax works. Something inside the arrow signs, such as digits, can be defined further. You need to memorize the colon equals, which defines something that can be defined further in BNF. The line means OR, so a digit is defined to be 0 or 1 or 2 or 3 and so on. An integer is defined to be either a digit or a digit followed by an integer. Is 412 an integer? Think about this in your head. Consider the following scenario. We have defined what a digit is and what a letter is. Staff code is defined to be a letter followed by a digit or a staff code followed by a digit. The question is, which of these staff codes are valid? Here are the answers. Did you get them all right? Let's go through each one. AD5E is invalid. You can easily see it doesn't end with a digit. Essentially, a staff code starts with a letter and continues with digits. F453 did just what we said. Why is it invalid? Well, have a look at the letter definition carefully. It only includes A, B, C, D and E, not F. F is not a letter in this code. D740 is valid. D7 is a letter followed by a digit. D7 is verified as a staff code, so D74 is a staff code followed by a digit. Now we know that D74 is a staff code, we can conclude that D740 is a staff code followed by a digit. EA52 has 2 letters at the start. E90 is also valid. A142857 is valid also. H122 is valid. D9 is invalid because the lowercase d is not recognized as a letter. Syntax diagrams, a diagrammatic way of representing BNF. Things that can't be defined further are represented inside circles. Here is how we would define the staff code from earlier using a syntax diagram. Shoutouts to George and Tom for helping me with this bit. Infix notation is what we're used to. That's great for us humans, but it's ambiguous to the machine. The machine prefers postfix notation or prefix notation, These are ambiguous. No brackets are ever involved. Remember our binary tree from chapter 5? It has even more uses now. This is pre-order traversal. Starting at the root, we go to the left until we can't anymore. Then we go to the right. Run your finger down the lines so you can track when you visit and record each node. With in-order traversal, we visit the left, then the root node, then the right. Essentially though, we just read from left to right. With post-order, we visit the left subtree, then the right, then the root node. We record each node the last time it is visited. Let's visualize a calculation in detail. The computer does calculations in this way. When you're checking your answer, you may want to visualize how the computer does it. The computer reads postfix from left to right, updating any numbers to the stack. When it sees an operation, it pops the first two numbers and operates on them. The result is pushed to the top of the stack. This continues until the computer has reached the end of a postfix, and all it has to do is pop the remaining value to give the answer. That's all my slides. Thank you for watching. Strike that like button and subscribe for more F453 related content.